Alright team, let's solve a Leetcode problem called group anagrams. It's a medium problem and the number is 49. So here is the problem statement. Given an array of strings, group the anagrams together, right? You can return the answer in any order. So if you don't know what an anagram means, an anagram is basically a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once, right? That's very important. So here you have an input vector, right? And if you notice, there are a bunch of anagrams here, right? So eat is an anagram, tea is an anagram, and 8 is an anagram, right? So your goal is to group them together and put them in a vector and return that vector, right? So tan and nat are also anagrams, so you see they are grouped together here, and bat doesn't have any anagram in the input, so it's by itself. So let's go to the whiteboard next.
All right, team. Imagine you have an input like this, right? You have a bunch of strings, and if you see carefully, we have a bunch of anagrams here, right? So eat, tea, and eight are anagrams. Tan and nat are anagrams, and bat doesn't have any anagram in this input, right? So the goal of this problem is to basically group these anagrams together and return as a result, right? Just for a moment, imagine you have buckets. Imagine you have three buckets here, right? How can you put anagrams in their own buckets? So here, how can you put eat, tea, and eight in its own bucket? How can you put tan and nat in its own bucket? And how can you put bat in its own bucket, right? If you can build some kind of a relationship between anagrams, right? Some kind of a relationship that identifies anagrams, I think you would solve the problem easily, right? So the secret here to solve the problem lies in generating some kind of an identifier, right? Let's call it key, right? Each bucket is identified by a unique key, right? And anagrams will have key in common, right? In this case, eat, tea, and eight will have one key. Tan and nat will have their own key, and bat will have its own key, right? The secret to solving this problem lies in generating these keys, right? If you can figure out a way to generate these keys such that you can identify anagrams, I think you have solved. All right. So now that you know that the secret to solving this problem lies in generating the keys, let's look at how we can generate these keys, right? So this is where the majority of the complexity for this problem lies, right? If you can figure out a way to generate the key, you have solved 99% of this problem, right? So for now, imagine you have a array of size 26, right? Each position in the array is defaulted to a value of 0, and each position represents a letter in the in English, right? So 0 represents A, 1 represents B, 2 represents C, 3 represents D, and so on until 25 represents Z, right? Then, given an input string, let's say S is equal to EAT, your goal becomes becomes to calculate the frequency of each character, right? So if I can count the frequency of each character in the input string S, that would be a way forward to generating the key, right? That we care about. So let's say we are counting frequency of each character in S, right? So E, I can go and mark position 4 to 1, For A, I can go and mark position 0 to 1, and for T, I can go and mark position 19 to 1, right? Once you have calculated the frequency for a particular string, right, that becomes your key. And the other reality is two strings, if they're anagrams, so let's say you have another string called A, T, E, they will have the exact same sequence, right? So for A, you will also have the for T, for this string, you'll also have the 0th position marked as 1 for A. You'll also have the 19th position marked as 1 for T, and you'll also have the uh, 4th position marked as 1 for T, right? So two strings, if they are anagrams, will generate the exact same uh, array sequence, right? And that's it. You have now generated the key for a particular string. Move on. Let me talk a little bit about how to generate or how to find the index of a particular character, right? So let's look at a fresh example here. Let's say your S is E-A-T, right? How do you find an index for E in the array, right? The secret here lies to doing some math, right? If you look up the ASCII table, you will find that each letter has a decimal value associated to it. So A is 97, B is 98, and so on, and Z is 122, right? So if you take the value for E, in value for E will be, so 97, 98, 99 will be C, 100 will be D, and 101 will be E, right? So if you take the value for E, which is 101, and if you subtract A's value, which is 97, right? This is equal to 4. And this 4 becomes your key in the index, in the array, right? So that's a trick to calculate the index of a particular character in your input string.
Alright, team. Enough talking, let's write some code here, right? So let's divide our function into two parts. In the first part, we generate the key for each string in this input vector, and we basically put them in their respective buckets. So all we are doing in step 1 is we are basically grouping all the anagrams together, right? And in step 2, we put all the grouped anagrams from the buckets into a result vector that we need to return, right? Okay, so let's write some code here. So the first question is, okay, how do we represent our buckets, right? And we can use unordered map, and the key to this map will be the unique key that we are going to generate in a moment. And we can represent the bucket using a vector of strings, right? Let's call this map buckets. Now comes the interesting part, right? For each string in stars, we want to generate a key, right? So let's go over each string one at a time. Const auto star in stars, and we said we are going to use an array of size 26, right? So let's define or declare that array. Let's say size 26. Let's call it frequency count. And let's fill this value array with all defaults of 0, right? Because that's what we want. We want to start from default of value 0. So once we have this, we can then go over each character in star, right, and calculate its index. So let's do const auto ref again, c in star, and let's count the frequency of each character in star, right? And the way we said we are going to do it is we are going to do c minus a, yeah, right? The value of a should be 97, and the value of c, you can look it up, right? If for a particular character, you will find its value in the ASCII table, right? And we said we are going to add 1 to it. So that's it, guys. This once this array is filled in, you have generated your key, right? And then the job becomes just update the map with the key and its respective value, right? So we can simply put our stir in the right bucket. So let's generate the key, and let's say the key is going to be standard string key, and let's convert our array into a string, right? So we can do that using begin and frequency dot end, right? And if we surround this by a string, we should convert our array into a standard string. So let's use this key and let's push back our stir into it, right? That's it, guys. With this lines of code, you have basically grouped all the anagrams in this input vector into their own buckets, right? Now you have almost solved the problem. Just because this problem requires you to return a vector of strings, we need to do one additional step. So let's do that step. So if I declare a vector here, let's say vector of strings, let's call it result, right? All we need to do is look at our buckets one by one. So let's use const auto, let's use structured binding here, key bucket, and let's go over our map of called buckets, and we can simply put the bucket in our result vector, right? So let's do a pushback on the bucket, right? So if we return this result at the end, we should have solved this problem. So let's run this, see what happens. There you go, accepted. Let's try to submit this, and there you go, beats 35%, accepted, life is good. So hopefully guys you enjoyed this video, and if you have any feedback or comments for me, please post them in the comment section. Thank you very much.